All right, well, Yang is going to talk about giving R a speed boost, and so I'll turn it over to Yang.
Hey, hello everybody. My name is Yang, and I'm from U of M, and I'm doing PhD in statistics right now. Today I'm going to share some tricks in R to increase the general performance of R. So first, let me ask you a question, okay? So suppose we have a variable x equals to 1, okay? And my question would be, is x an integer or a vector, okay? I think if you're coming from C or C++, you would definitely say x is an integer because you're so familiar with this kind of definition of variables, integer x equals to 1. Okay? However, in R, when you define a variable, even it has only one value in the variable, it is a vector. Okay? Because when you look at the length of this object x, the length is 1. Okay? So that's a very fundamental idea of R. A lot of data are in either vectors or matrices. Okay? So that's why we need to vectorize our code. Okay? So a lot of common tasks can be easily vectorized in R, especially by using some built-in R functions. So for example, here's a very basic example. If I want to calculate the sum of squares of a vector of any length, okay? So if you are transitioning from C or C++ to R, you're probably writing a loop because that's the only way to do it in C or C++. Basically, you're just looping through the this vector and calculate the square at each time. Okay? So with R, with the built-in function in R, so keep in mind R, everything is a vector. Okay? So we can write these lines of loops in one line of code. Okay? So first I calculate x squared. So this operation takes the square of each element in vector x. Okay? And then I call the built-in R function sum. Then R calculates the sum of this vector automatically. And there are a lot more examples for vectorization. For example, matrix multiplication, we do x. This is a matrix multiplication operator y, and also cross product of two matrices. And you can calculate the column, the mean and sum of each column or each row by using some built-in R function, cosums or comeans. These functions are extremely fast because they are written in C. And another important part is using apply function. So apply function is a family of different functions. So for example, it has the apply function. So in the apply function, it takes 3 arguments. X is a matrix or multi-dimensional array. And we can apply any function to any margin of the matrix. We can either apply to the row of the matrix or the column of the matrix. And you can also use lapply function, which takes x as a list or vector as input argument, and it returns a list. And similarly, we have sapply function, which is almost the same as lapply function, but it returns a vector instead of a list. Okay. So why do we use apply function? So apply function, in many cases, it doesn't necessarily improve the speed of our code, but what it does is improve the readability of our code. It's much easier to understand what our code is doing if you use apply function, because a lot of times you can achieve your goal in one line of code instead of writing a very complicated nested for loops. Okay? And another benefit of vectorizing your code is you can do parallel computing very easily. Okay? So first of all, what is parallel computing? So I can show you guys a very good video which illustrates this idea. Okay? So basically in this video, so this is how by default R works. You only use one CPU core. Okay?
2, 1.
So it's drawing a picture, one pixel at a time.
Let me speed it up.
Drawing a smiling face. Okay, so that's called, we're only using one core to do the task. So we do each step sequentially, not at the same time. Okay, so what is parallel computing? There's a, so if I jump the video to the later part. Okay.
Painting demonstration.
So this is how parallel computing works.
9, 8, 7, 6, 5, 4, 3, 2, 1.
Okay. So I think this illustrates what is parallel computing. So basically it's performing the task at the same time using multiple tools. In our case, it's using multiple CPU cores. Okay? So how do we do parallel computing in R? So by default, R only uses one CPU core on the local machine. So there are several ways doing parallel computing in R. So the first thing is use multiple cores on a local machine. Okay, so if I want to use multiple cores on my own laptop, I can use the parallel package, which is a built-in R package, or the for-each package. And if you want, if you have a cluster of connected workstations, like 100 different computers, you can use this Snow package to send the job to 100 different computers and do the work simultaneously. So I'm going to show an example by using the MCLapply function in the parallel package. So notice MCLapply is very similar to the lapply function. It means multi-core lapply. Okay? So I load the package parallel, and I type the command detect cores, and it's going to tell me how many cores my computer has. So in my case, I have 4 cores. Okay? So actually, I have only 2 physical cores, but I have 2 threads on each core. So the system side we have 4 cores. So to show how the MCLapply function works, I'm going to do a very simple simulation study on the outcome of the famous multi-hole game, which is also known as Let's Make a Deal. So what is this game? Okay. So basically you have 3 doors. So this is a fun game. Okay. So behind one of these doors is a car, and behind each of the other 2 doors are ghosts. So let's first click on one door. So it reveals that in door 3 is a ghost. Okay? So now you're given the option whether you should switch your choose. Should we switch? Yes. We switch to door number 2. Probability. Okay. Yeah, so in general, if you switch 2/3 of the time, it should be a car. Okay, so unfortunately in this case we end up with no. Okay. So if we do a combination study, say we play the game 10 million times, and 2/3 of the times we'll end up with a car we switch. So let's do this in R. Okay. So I write a function to simulate the outcome of the game. And now I want to run the function 10 million times. Okay. So I can time my process. In the first process, I use 4 cores and MCL apply function. And system, the total time is 53 seconds. And here I use the L apply function, which only use 1 core. And the total time is 87 seconds. Right? So the multi-core MCL apply function is faster. But I think most of you have noticed that it's not that fast because it takes 53 seconds. But we're using 4 cores. It should be around 20 to 23 seconds. So why is 53 seconds? It's because when you use multi-core package, you're sending your information, your data, to all of the cores. So this process takes some time. And also when all the cores, when their job is done, you need to collect the results from each of the cores. So this process also consumes time. So a lot of times, you won't be able to see the total time proportional to the number of cores used. That's very normal, okay? And if we check the outcome, it's approximately 2/3, okay? Which means 2/3 of the time will be in the game. Okay, so that's for the vectorization part. However, a lot of the times we can't use any of the vectorization or parallelization tricks because consider in the following example, say we want to run a Monte Carlo simulation or do some optimization such as gradient descent. So in this kind of algorithm, your current step is dependent on the outcome of the previous step. So you can't parallelize your code. So you have to use for loop in this case. And for loops are not always bad. Okay? So what is really bad is called dynamic memory allocation. Okay? So for example here, we start data with a null object. So R has no idea the size of the data. And in this for loop, at each step, we see data I. So each step, the size of the data is increasing. Okay? So this is called dynamic memory allocation. And this is going to slow down your code significantly. Because in each iteration in the loop, R needs to copy-paste memory. That's very time-consuming. So instead of doing dynamic memory allocation, always specify the size of your object before you run the loop. Okay? By doing this, the size of the object won't grow each time you run the loop. That's gonna save you a lot of time. And even if we do the optimization here, R is still pretty slow for running for loops. So how do we get around it? You can implement C or C++ code. So R has very nice interface. It has a .c or .call function to call pre-compiled C or C++ functions. And recently there's a RCPP package. It makes writing C++ function really easy. Okay, so now I'm going to do a simple example of calculating the sum of any vector. I know this can be done in R by using the sum function, but I just want to show how the C++ works. Okay, so to start with a C++ function, we define the header and namespace, and this line defines which function we want to export to R. So in this case, we export some CPP function into R. Okay, and then we just write a loop, a for loop, to calculate the sum of the vector. And once we're done with the C++ code, we can save this code in a separate file, okay, called sum.cpp.cpp. And in R, we use the source CPP function to compile this C++ file. And once this file is compiled, we can directly call the function name, sum.cpp, which is exactly the same as the name of the function we defined here. Okay? So if we calculate the sum from 1 to 10, it's 55. Yeah. Yes, you can define the compiler in your system for R. So you can either use GCC or Apple compiler. You can choose the compiler of your choice. Yeah.
Does it recreate? Does it recompile every time you source the file, or does it just use the library option?
Do you mean by running source CPU? Yes. Yes. Yeah. But if you run the package, it only compiles once when you build a package. So it's really nice. And now we can write an R version, which is using a loop in R. Okay. It's going to do the same thing as a CPP function. So we can compare their speed. Okay. If I use the R benchmark package, I can generate a vector of length 10 million and calculate their sum by using these three different functions. So sum R, this is R function we just defined, and the CPP function, and this is a built-in R function. Okay? So for their speed, the C++ function is almost the same. It's the same as the built-in R function sum. And of course, if we write a loop in R, it's going to be the slowest. It's actually over 300 times slower than the C++ function. And why the R built-in function sum is so fast is because it's also written in C. Okay? So what the function does is calls a C function. And for the detail, you can see Winston's GitHub Miro. So to summarize what I've done today, the first thing you should keep in mind is always try the built-in R function first, because a lot of them are written in C. It's definitely going to be really fast. So before you try to write your own version of something, just try to Google if there's anything in R already exists or not. And of course, you should vectorize and try to parallelize your code. And avoid dynamic memory allocation at all costs. And for loop is not that bad if you avoid dynamic memory allocation. And also, if you have to use for loop, you can write a C or C++ function to improve the speed. Okay. Questions? Yeah.
Regarding the revolution part, I heard that revolution was giving free software on the package that they build for parallelization to the universities. Did you have a chance to use their package and compare against the parallelization that you use?
Do you mean the for each function?
No, there is the apply function that you use. I was just interested to know what the build process was.
Do you mean this function? Because this library is built by R Revolution, I think.
As well.
No, Parallel is built by our team, and ForReach is built by our Revolution team. I think.
There was one function called Revo Exact, which we did a POC with Revolution R, and they were selling at the time before they went accurate. I'm just curious to know what the build versus what's available
I've never tried that package before, so I can't tell. Sorry. Yeah. But for these two packages, I find by using the Parallel package is faster than using the 4-inch package. Yeah.
I was trying to vectorize the function I had written, and I ran into a problem because within the function I had an if-then-else statement, and it was forcing me to use a for loop. But then I found that there's a built-in function in R called if-else that you do the conditional in a vectorized way, and that helped. That enabled me to actually vectorize the function I was working with. I don't know if everybody knows that, but that's a pretty cool method.
Yeah.
So going back to the source CPP file that you addressed, is there any way to use an object, to load in an object file without recompiling it every time? Could we just, make it somehow?
That I don't know. I'm not sure. Yeah. So what I do is always, most of the time, just compile to a package, so I don't have to recompile it every time.
Question on parallelization of
Yeah.
R. Did you have a chance to use it in distributed environment like Hadoop
Not Hadoop, but in our school system, we have like 7 or 8 different machines that can run cluster or something by using the Snow package. Yeah, but not like a Hadoop system.
How do you compare the result? Efficiency, did you see a lot of improvements?
What's that?
In terms of efficiency of the computation, did you see a lot of improvements?
Yeah. Because on each machine we have, I think 8 cores. So if I do 8 machines, I have 64 cores. It's definitely way faster. Okay, that's it.